In this video, I'm going to discuss about Penck's model of cycle of erosion. So, Penck model of cycle of erosion was given by Walter Penck, who was a German scientist, and he rejected the time-dependent division model. And he presented morphological analysis to explain about the landscape development, and his objective was to analyze the ratio between the intensity of endogenetic processes and the displacement of materials by exogenetic processes during the landform development process. Some of the terminologies, so because he was a German scholar, he gave many terminologies in German language itself. So those are Entwicklung, which is development, which is also known as development in English, and Aufstehende Entwicklung, which is accelerated rate of development, Gleichförmige Entwicklung, which is uniform rate of development, Absteigende Entwicklung, which is decelerating rate of development. So we have accelerated development, decelerating rate of development. In between this we have uniform rate of development, which is Gleichförmige Entwicklung. And primarum, which is characteristics of landscape before upliftment, and endrum, that is landscape at the end of erosion, and Boschingen, which is also known as gravity slope, Haldenhang, which is also known as wash slope. So instead of using different stages like youth or maturity or old stages, he gave different phases to explain about his theory. So these phases are prima rumph. So initially prima rumph is there, which is Penck plain. It is the initial landscape with evidences of erosion but with low altitude and featureless land. So these are some terminologies. And waxing or accelerating phase. So in this phase, initially rate of upliftment is slow but later it accelerates. So during waxing period, the upliftment is accelerating at the end, but initially though upliftment is slow. An increase in upliftment and channel gradient. So because of the upliftment is there, the channel gradient also is increasing, and because of that there is rise in kinetic energy and flow velocity and discharge of rivers, and the rivers degrade their valleys by down cutting. So because of that rivers, and because of the down cutting, they degrade their valleys and forms a V-shaped narrow deep valley. So it is narrow, not broad, and the rate of upliftment is more than the valley deepening. So in this stage we can see that the rate of upliftment is more. So rate of upliftment is more but the valley deepening is less, so that absolute height is increasing in this stage. So this stage is known as waxing or accelerating phase. This phase is known as waxing or accelerating phase. So in accelerating phase, so upliftment is more, but the down cutting is less. So here we have the graphic presentation. So in this we have, this is the base level. So here we have time, the horizontal line, the vertical line we have altitude or height, and this is the valley floor. And this is the beginning stage, initial stage. There is prima rump, so there is a featureless landform. Slowly it is uplifting, and in this upliftment phase is accelerating, so the upliftment reaches a height here, this phase. So here the upliftment is increasing continuously, as well as the rivers are down cutting these valleys. So this down cutting, and this is forming a V-shaped valley, a narrow valley it is, and this down cutting is the rate of down cutting is lesser than the upliftment, so the height also is more in this stage. So as we can see that down cutting is more and the narrow valleys are there, and here this upliftment is reducing, the slope height is reducing slowly it is reducing, and here the narrow valleys become a wide broad valley because of the lateral erosion. So we can see that because of the lateral erosion it becomes a broad valleys, and it forms inselbergs, and at the end it becomes endrum. So at the beginning it is called as prima rump, and at the end it is called as endrum. So altitude and relief increases to its maximum. So here we can see that the relief feature also is increasing, the altitude is increasing to its maximum, and slopes of valley sides become convex in plane. So valley sides becomes convex in plane, and the side slopes are continuously steepened due to valley deepening, and the radius of convexity of slope decreases as the steeper slope segments retreat parallelly with time. So here we can see here this valley, the slope is like this, the slope is like this. So the here it becomes a concave slope. So convex slope, here it is convex in shape, but it becomes a concave later it becomes concave in shape. And these slopes are retreating. So here we can see, here there is two slopes are there, but here at the end it is not there. At the end it is not there because it is retreating. The slopes are retreating. So but it is a parallel retreat, that's what he says. And the radius of convexity of slope decreases as the steeper slope segments retreat parallelly with time. As the time passes, there is more accelerated upliftment and degradation of the primary peneplain, and Primaram is surrounded by a series of benches called as Piedmont trepan, and those benches develop into a Piedmont flat known as Piedmont flank. So this the Primaram becomes a Piedmont flank. So here we can see that it is Piedmont flank as he says. And so second phase is uniform, the phase of uniform development of landforms. It is divided into three subphases. The first phase is rate of erosion is less than the rate of upliftment, and so the absolute height increases, and heights of water summit and valley floor continue to increase but at slower rate than the first phase. So here also the height is in absolute height is increasing, and the heights of water summit and valley floor also continue to increase, and but the rate is slower than the first phase. The maximum altitude is attained in this phase. Valley sides are characterized by straight slopes, and this phase is called as uniform development because of the uniform rate of valley deepening and because of the uniform rate of development. So this phase is known as uniform development of landform phase. So second phase, so in this absolute relief and relative relief remains constant due to denudation through upliftment, though upliftment continues. So here it is increasing, but here the absolute relief and relative relief remains constant due to denudation through upliftment, though upliftment continues. Though upliftment continues, the downcutting is more, so the heights are constant. So the rate of erosion matches with the rate of upliftment, and the third phase, upliftment stops completely. So if upliftment stops, this height of the slope is going to reduce, but the erosion continues. So the absolute relief continues to decrease, but the relative relief remains constant as it matches with the rate of valley deepening. And the third phase is known as phase of waning. So first phase is phase of waxing, then second phase uniform development phase, then third phase is known as phase of waning. This phase is characterized by progressive lateral erosion and valley widening, and a decrease in the vertical downcutting or valley deepening, and erosional process is dominating in this phase with down wasting and absence of upliftment. So here there is no upliftment at all, and in this absolute relief and relative relief decreases. In this third phase, it is going to the reliefs are going to decrease, and the decreased channel gradient and kinetic energy leads to decrease in downcutting, and continuing parallel retreat of the valley side slopes has two segments. So these segments are known as upper and lower segments. The upper segment maintains steep angle, whereas but there is continuous lowering of the ridge crest and the gravity slope or so this forms a gravity slope, the upper segment. So in the mountain we can see that so this is the gravity slope or the upper segment, but the down this is known as a wash slope, this is known as gravity slopes. So because of that a steep angle is there, this maintains a steep angle, but there is continuous lowering of ridge crest. And the lower segment we can see that lower segment of the valley sides are called wash slopes or Halden hang. Because of that this slope, this structure washes the materials which are there in the flow of the river. So during the flow of the river, it washes the material, whatever is there on its way. And at the intersection of these segments, break in slope is produced and the wash slope expands. So here, so if intersects these, where there is intersection of these segments and there is a break in this slope, and the wash slope is going to expand. And in this last phase, in the last phase, gravity slopes are reduced to sleep-sided conical residual called Inselbergs. So at the end, it's going to form Inselbergs. So in this image, we can see that. So finally, they are formed Inselbergs. So all these slopes, gravity slope is reducing. So only the wash slopes are left here. So they are forming Inselbergs here. And so there are three phases of, and so he explained three phases, and these Inselbergs are consumed, and eventually, and the whole landscape is dominated by a series of concave wash slopes. So only the concave wash slopes are left, and such extensive landscape produced at the end of this phase is called Endrumpf. Evaluation of this theory. So because this theory was explained in German language, the interpreter, so the translator interpreted it in different ways. So the poor interpretation of German language by translator was a drawback for this theory, and the parallel retreat of slopes was criticized by many, and how it can happen like that, and continued upliftment was criticized by many, as well as this theory he couldn't this theory was not much explained by Penck because he died early, and because of that he couldn't explain this theory very well, and this theory was in German language. It was difficult for many scholars to understand and to translate them into English. So this is all about Penck's theory of Penck cycle of erosion. So in this theory, so from primarum it is going to upliftment, and during the upliftment and the vertical down cutting and V-shaped valley, initially it has a convex slopes, and these convex slopes finally turning into a concave slopes, and the gravity slopes are disappearing slowly and becoming